If a bridge could have everything, money, ambition, and disaster, this would be the one. The Sam Houston Tollway Bridge rises above the busiest shipping corridor on the U.S. Gulf Coast, the Houston Ship Channel, a waterway that moves more cargo each year than the ports of Los Angeles and Long Beach combined. Here, a single mistake can freeze a trillion-dollar economy. And that's exactly what happened. In January 2020, Harris County shocked the nation. All construction on the $1.5 billion replacement bridge was ordered to stop immediately. Cranes locked, crews dismissed. The project, already 40% complete, was suddenly lifeless. Behind the silence, a discovery that the bridge's design might not withstand the wind and stress it was being built to resist. It was the first time in decades that a U.S. megaproject of this scale was shut down mid-build for structural concerns. Nearly $300 million evaporated in redesign costs and delays. The headlines called it Houston's billion-dollar blunder. But the truth was more complicated, and far more interesting. This is the story of how America's next great crossing nearly failed before it opened, and how engineers fought back to save it, bolt by bolt, cable by cable. To understand how we got here, we have to go back to what the bridge was meant to fix in the first place. The East Sam Houston Tollway, better known as Beltway 8, loops the entire city, a concrete ring that keeps one of America's busiest metros moving. At its toughest point, the road leaps across the Houston Ship Channel, a corridor packed with oil tankers, barges, and chemical freighters. The original bridge opened in 1982. 4 narrow lanes, 175 feet of clearance, adequate then, but a bottleneck now. It squeezed both traffic and shipping, and as Houston grew, so did frustration. The replacement plan was audacious. 2 parallel cable-stayed bridges, northbound and southbound, each carrying 4 lanes plus wide shoulders. Together they'd double capacity and remove all support piers from the channel, opening a clear 1,320-foot span with 188 feet of vertical clearance, enough for the next generation of supertankers. Construction choreography was surgical. Build the new southbound span beside the old bridge, shift all traffic onto it, demolish the 1982 structure, then raise the northbound bridge in its place. All while ships continued to pass beneath every day. On paper, it was perfect. A design that combined efficiency, safety, and visual grace. Renderings showed gleaming white pylons soaring 515 feet above the water, stay cables fanning out like strings of a harp. But hidden in those elegant lines were details waiting to unravel. Before long, another bridge hundreds of miles away would collapse, and Houston's dream design would suddenly find itself under a microscope. March 15, 2018. A pedestrian bridge at Florida International University snapped without warning, crushing 6 people beneath it. The tragedy shocked the nation, but for engineers it carried an especially dark echo. The firm behind that design, Fig Bridge Engineers, was also the engineer of record for Houston's new cable-stayed spans. In the months that followed, FIG came under scrutiny. So did every project it touched. Out of caution, Harris County Toll Road Authority ordered an independent review by KOI Engineering, a team tasked with rechecking every calculation, every assumption. While construction continued, KOI built its own digital models. Then the findings landed. 21 major issues. 3 categories so critical the county had only one choice: stop everything. First, wind. Loads used in the design were underestimated. In a partially built bridge, even gentle gusts can set the deck swaying, and those vibrations multiply as each new segment extends. Second, pylon capacity. The tall concrete legs sweep gracefully, then kink near mid-height. Beautiful, yes, but that curve concentrates stress. KOI found the kinked zones too thin for extreme construction stages when forces aren't yet balanced by completed cables. Third, foundations and staging. Pile capacities were optimistic, and live traffic on the adjacent span hadn't been fully modeled, not catastrophic, but it ate away the safety buffer every Century Life bridge needs. January 7, 2020, Harris County orders a full stop. FIG bridge engineers are dismissed, cranes idle, rebar rusts in the Gulf humidity. The project that promised progress now stood as a monument to miscalculation. Yet out of that pause came an opportunity, a chance to rebuild trust, literally from the ground up. Late 2021, after 20 months of silence, work resumed. Commissioners approved a $291 million redesign package, pushing total cost past $1.45 billion. The new team's mission was simple but daunting: make the bridge safer, stiffer, and more predictable. The first change came at the core. Out went the heavy all-concrete deck. In came a composite steel and concrete system, steel girders supporting a concrete slab above. The hybrid deck is lighter yet stronger, resisting wind-induced vibrations during construction and providing long-term durability once complete. Next, the pylon geometry. Engineers thickened and simplified the curved kink regions, added denser reinforcement cages, and cleaned up the force flow between cables, tower, and deck. Now loads travel exactly where the drawings say they should. The team also reevaluated every foundation, confirming pile capacities under new wind and seismic models, and resequenced construction so that live traffic and staged loads never overlap dangerously again. In effect, the bridge was reborn. A tighter, leaner structure that performs better both in its temporary and finished states. By mid-2025, new pylons gleamed against the Texas sky. Cables rose like silver threads over the water. The first span is now slated for 2026, the twin for 2028, years late, but wiser for the wait. What began as embarrassment had evolved into education, a masterclass in why good engineering isn't fast and why humility might be a bridge's most important material. Every great failure leaves fingerprints on the future. The Sam Houston Tollway Bridge now guides how agencies nationwide approach mega projects after the Francis Scott Key Bridge disaster and decades of maritime strikes. Removing piers from the channel isn't aesthetic flair, it's safety. Raising clearances saves lives and billions in commerce. And rigorous peer review is no longer optional. When the new bridge opens, Houston will gain 8 lanes of traffic, broad shoulders for emergency stops, and, for the first time, a shared-use path for cyclists and pedestrians high above the water. It will also gain something harder to measure: trust. Trust that lessons were learned, that design integrity outweighed deadlines, that verification triumphed over ego. The 2020 pause cost money and time, but it also prevented uncertainty from becoming tragedy. That's what real engineering does. It questions itself before gravity does the questioning. One day soon, tankers will pass under a pier-free opening without hesitation. Commuters will glide across decks that feel steady even in a Texas crosswind. And the cameras will move on because the bridge will simply work. In the end, the measure of success isn't ribbon cutting. It's quiet reliability. Steel, concrete, and patience fused into a structure built not just to stand tall, but to stand right. After all, in infrastructure, silence is the sound of something done well.